understand what's really going on with them. They're not trying to be mean, they just don't know what they're saying. I don't want you to be one of those people. Okay? 3 different ways to present percentages. One is as a fraction. Okay, a total of 13,000 newspaper employees lost their jobs. Newspapers are going down. Why?
Technology.
Because you can get everything you need off the internet, can't you? How many of you take a newspaper? They're kind of outdated. Gosh, that was printed 6 hours ago. I can get 5 minutes ago on the internet. Okay, so what's winding up happening is that the number of employees, the number of people in that industry is going down. It says 13,000 employees, 2.6% of the newspaper workforce lost their job. With that information, could you figure out how many people total there are in the newspaper industry? Well, you could. Okay. What you would wind up doing is you would take 2.6% and you convert it first back to a decimal and 2.6%. We don't know how many people total there are. X is going to be the total people equals 13,000. Are you okay with solving that? Does that make sense? Divide by, we get out your calculator, divide by the 0.026. X is going to give you a fairly large number. Okay. So one way that fractions or percentages are used is as a fraction of the whole population. Okay, 2.6% of the whole population of people involved in newspaper industry. Okay. A second way is to describe a change. Okay, a particular stock fell 15% last week. This is just something that was made up, not an actual stock quote from last week. Okay, Citigroup fell 15% to $44.25. When you're reading something like this, do you know from that information what the original price of the stock was? The answer is, well, it's not in that sentence, but we could figure it out. Did it gain or lose its value? It lost 15%. And after 15% was taken away, it was worth $44.25. We're going to talk about how you figure out what the original value was. So one way to use percentages is as a fraction. A second way is to describe how things are changing. Understanding this is going to be important because you're all going to start your retirement accounts very soon, aren't you? And you're going to be looking if they're going up or down. And they'll do some of each, hopefully more up than down. A place where you will often see percentages used in advertising is to compare one thing to another. Okay. This new super duper battery lasts 125% longer than the standard one, but costs 200% more. They won't throw in that it costs 200% more. You have to figure that out on your own. First, is it possible for something to be 125% bigger than something else? I don't know. That's okay if you don't know. That's why you're here. It can be bigger. Okay? I'm bigger than I used to be, height-wise. There was a point I was only 21 inches long. Well, there was a point I was only about that long. Of course, that was before I was born. But when I was born, I was about 21 inches long. Well, I'm a little bit more than 21 now, 21 inches. A little bit more than 21 years old, too. Okay? It is possible for things to be more than 100% bigger than what they were. Here's the important one. It is not possible to be less than 100% smaller. If you're 100% smaller, that's the whole thing, isn't it? 100% is the whole deal. Okay? So it's not possible for something to go less than 100% smaller, except in situations where you can go into debt. Okay? Then you can go less than 100%, and now instead of having $0, you have negative dollars. Is it possible to have negative dollars? Yeah, that's called debt. Okay, but what you need to recall here is there are three primary places where percentages are used: to describe fractions, a portion of a whole group, to describe how something changes, it can increase or decrease, and to compare. Bless you. Okay, so those are the three different places that typically you'll run into some use for percentages. For example, an opinion poll finds that 64% of 1,069 people said that the president's doing a good job. How many people said the president is doing a good job? Now, we're not getting into things like surveying techniques, because in the real world, is it important to know how the survey is taken? Yes, it is. Very important. Early on, who was projected to win in 2016 for the presidential election? Clinton. How'd they get those numbers? Was it just wishful thinking on the part of the media? Well, yes, part of it was. But how did they get the numbers they got? They actually did surveys. Their surveys were flawed. You know where they went to do most of their surveys? Cities. Dead serious. Okay. If you look in Ohio, okay, in the state of Ohio, and you can go on a search engine and look this up, pretend that Ohio looks something like that. They did surveys in this area, and this area. The 3 C's. What are the 3 C's in Ohio? Columbus, Cleveland, Cincinnati. Okay? If you go online and you do a search for the county by county results on the 2016 presidential election, those 3 spots were Clinton. You know what everything else was? Trump. I'm serious. Go to a map. Ohio is all red except for 3 little blue dots. The way that they got Ohio going to Clinton was they just went to the cities and talked there. That's not the bulk of Ohio. Okay. So, and we'll talk more about polls and things later, but I want you to be aware that when you hear about opinion polls and things, you need to be very careful who did the poll, who did they talk to. It's not necessarily important that they talk to zillions of people, which we'll talk about, but you got to be careful to talk to an appropriate representative group. Or you can get a poll that says anything. You could even get a poll that shows Snoopy's going to be elected president if you poll the right people. Okay, 64% said that they support the job the president is doing. Well, the question is, out of the 1,069 people who were asked, how many people actually said that they thought the president was doing a good job? What was the actual number of people? Okay, yeah. How do you figure it out?
I did 4 times 1,069.
Okay, you convert the percentage back to a decimal. And this is an important move often when using percentages, is the first thing converted back to a decimal. Percent actually means something. Okay. Per means part of in Latin. Gosh, Chuck, I didn't know we were going to be studying Latin in here. I thought this was a math class. Per means part of. What does cent mean? Century, 3 cents. How many years are in a cent? Yes, sir. Part of 100. That's it. You got it. Cent means 100. It's a Latin word for 100. Like century is 100 years. Why do they call pennies 1 cent? Because they are 1 of 100 of a dollar. No way. That's That's why it's called a cent? Yep. So percent means part of 100. If you're going to convert a percent back to a decimal, you slide the decimal 2 places. 2 places is 100. So in the percent of 64, you would go 1, 2, and you get to 0.64 times 1,069. Now, think. Don't just plug numbers into your calculator. Before I start poking in numbers, okay, should my final answer be bigger or smaller than 1,069? Smaller. Please don't give me an answer of 2,000. Okay, sometimes people just get whipping numbers around and whatever the calculator says has got to be right because it's the calculator. Okay? All it does is messes with the numbers the way you tell it to. So we're going to do 0.64 times 1,069 equals. Second thing, we're talking about what here? People. Don't go giving final answers like this. What's wrong with that final answer? I pity that last person. Would you really like to be 0.16 of a person? I'm not sure what's missing, but there's a whole lot of parts that need to be put there. Would this be 684 or 685? Okay, and you could just put, I rounded it off, 684, or you could say there was some extra and I know that needs to.
I thought you always had to round up for like decimal at the end. Counting people.
Well, if you're counting people, yeah, I'll go either route, okay, with something like this. 684, and what you would really wind up putting down is 684 or 685. Now, the reason that you really don't know is because if you're listening to the news, first off, is that 64% exactly 64%? No. Or is that something that's already been rounded off? It's been rounded off, hasn't it? It might have been 63.53%. Rounded up to 64. It might have been 64.444982336. Rounded down to 64. So when you get stuff off the internet, the news, whatever, realize that it's already been rounded. Which is why I said I would take either number. Because you don't know if 64 is actually bigger than the actual percentage or smaller than the actual percentage. The actual percentage is around 64. So do you buy that on either 4 or 5, either way? Okay. But please don't give a percentage or a decimal point of people. Okay, that just hurts. Okay, so make sense? Everybody's good with that? Okay. Go ahead and multiply it out. It's about 684, or if you want, 685. Okay. So what this really means is about 684 people out of 1,069 said that they approve of the job the president's doing. Yeah.
What unit number are we on? I just didn't have time.
This is 3A. Yeah. Where are we, Chuck? Yeah, we're in 3A. Okay, now, you got to be careful when you're talking about percentages and changes. Sometimes in presentations, people either accidentally or with intent will pitch things one way or another to make it look like, well, our side's right and their side's wrong. I know that shocks you that somebody would actually do that. Okay? But it happens. There are several ways to measure change. One is what is called absolute change, and the other is relative change. Be careful, they are very different. Absolute change describes the actual increase or decrease from a starting number. Now notice that starting number is called a reference value. The reference value is what did you start with. In the last problem, the 1,069 was the reference value because that's how many people we talked to. Make sense? From there, you're moving to some new value. Either things are increasing or things are decreasing, and it can happen either way. The new value that you're moving to, okay, is cleverly called the new value. To get the absolute change, okay, be careful. Pay attention to this. Absolute change is always the new value minus the reference value. But Chuck, sometimes it's going to be negative. That's right. Sometimes it will be negative. Okay? Get yourself a nice job. You go out and buy a new car. I would encourage you to buy a 3 or 4-year-old car, but you like the shine on the new one. So you took a shine to it. You paid $21,600 for it. 2 years later, any idea how much your $21,600 car is going to be worth? On average, about $16,000. Okay, the question is, what is the absolute change in the value of that car? Did the car go up or down in value? Down, so will the change be a positive or a negative change? It's going to be negative. So does that make sense that sometimes you're going to get negative numbers? The new value is going to be your 16,000. The reference value, the starting value, is 21,600. What's that going to give you? If you take 16,000, it's okay to use your calculator. So if you take the 16,000, subtract the 21,600, do you get a negative 5,600? The absolute change is a negative 5,600. What's that tell you about the situation? You've lost $5,600. You've lost it. Can you get it back? No. You can't. It's gone. Well, why? Because the car's not worth what it was. You can't sell it for any more than $16,000. You plump down 21.6, all you're getting back right now is 16. You've lost it. Okay? Does that make sense? The absolute change is a decrease of $5,600. Does that make sense to everybody? Okay. The second way change can be, and I'll erase this, remember the $5,600, and we'll keep our reference and our new value up there at the top. The second way that you can talk about change is relative. Relative change is what allows you to then move into percentages. What percent of the value of the car have you lost? That is relative change. Because now you're going to compare it back to the original and talk about how much change there has been compared to the original value. To do that, here we go. You take the new value minus the reference value. Well, we know what that is. That's a negative 5,600. And you divide it by the reference value. Why do you use the reference value and not the new value? Because you're talking about, we started somewhere and we've changed, haven't we? And we want to know how far have we moved from where we started. Does that make sense? So the number that goes in the bottom is going to describe where did things start on this car. And we're going to compare where did we start to how much have we moved. Does that make sense to you? Bless you. When you plug this into your calculator, divided by the 21,600, yeah, this is right about what it's going to be, a negative 0.259 just run with 3 decimals, unless we're talking dollars. And if you're talking dollars, you should use how many decimals? 2. Okay, is everybody okay so far? And then notice over here to the far right-hand side of this equation, you multiply by 100. Why do you multiply by 100? Percent. Remember, we're talking about percent, which is part of 100. So you take this times the 100. And that'll give you a negative 25.9. And then to tell everybody it's out of 100, use that symbol afterwards, which everybody has agreed to say, yep, that's the percent sign. The percent sign means that part of 100. Yeah?
Do we never round up unless it says to?
You just leave it there. When I put the .259 down, I'd already done the rounding because it's .259, 259, and it goes on. So I had already done the rounding, yeah, to get it to 3 decimals. If you wanted to, would it be completely wrong to round this to a negative 26%? No. Yeah.
Is this the same thing as like the percent change thing?
Yes.
That's like new minus original over original?
Yep. Where the reference value is the original. Okay, the original value of the car, 21.6. There it is, new minus original. Yes. Now, what's this tell you? How much of your money have you lost on this car in 2 years? A fourth of it. A fourth of your money is lost. Do you see that? This is why I buy 3, 4-year-old cars, because I don't have $6,000 to just throw away in a couple of years. Do you? Now, if you buy a 3 or 4-year-old car, is it still going to go down in value? Yeah, but it's about $1,000 a year instead of $2,500 a year. It's a lot less decline, so you lose less money. Okay. The diversified portfolio grows from 1,500. Here's your retirement. It grows from 1,500 to 2,250. We could look at the 2 different ways to describe the growth of your retirement account. Okay? First, we could look at the absolute change. The absolute change would be what? What's the new value here? Is it the bigger number or the littler number? Be careful. The bigger number is not always the reference number. Yes, sir?
750.
Okay. The change is 750. You're absolutely right. It's gone up $750, hasn't it? Which is kind of a cool deal, because you know how you made that $750? You said, take that money and do something with it. And you know what else you did? You just walked off. And you come back later, and guess what? They got $750 for you. Wow. Okay? Okay, so the new number here. What's the new number on this? The 2250. That's where you are now, isn't it? What is the reference value? That's the original value, the 1500. So this is going to give you then the 2250 minus the 1500. The absolute change, $750. One way to look at how things have improved is like this. What's the other way? Relative change. What percent increase? Is this a good percentage increase? Yeah, this is sweet, especially if it's for like a year or something. This is really cranking. The relative change is, oh wait a minute, it says the absolute change over the reference value. This is another way of saying the new minus the original over the original. Okay, going with the pattern, I forget who pointed that out or asked if that was how it works. But remember, the absolute change is this computation here. So even though it just says absolute change, it really is still saying subtract, isn't it? Because absolute change means to subtract. And what you do is you take the absolute change and you compare it to where were you at the start. Well, in this case, where we were at the start was this $1,500. The amount of increase was $750, which gives 0.5 times 150%. Is 50% growth in an investment a good deal over a year? Yeah, that's cranking. Can that ever happen? Yes. Okay. Are you okay with this? Does it make sense? This is something that I'm going to ask about on quizzes and tests and stuff, because regardless where you go in life, are you going to see changes in the amount of money you have? Yes, whether it be in investments or whatever. And I want to be sure that you have some idea where that percent change information comes from, or how to figure it out yourself. Here's one. You bought a computer 3 years ago, $1,000. Today it's worth $300. Is that any surprise your computer went down in value? Okay. What's the absolute and the relative change in the computer's value? Well, the first thing you got to do on these, remember, whether you're doing absolute or relative, you've got to know what's the original value and what is the new value, or what's the relative value and what's the new value. What's the starting value on this? What's the original value? 1,000. So right away, just label this. Here's my original. What's the new value? 300. Now, to get the absolute, okay, here we go. The absolute is the new value, the 300, minus the 1,000. Does it make sense that the absolute change is a negative value here? What does a negative value means happened? It's lost value. It's gone down, hasn't it? Computers are never an investment because they don't go up in value. Okay, so there you go. There's your 300 minus your 1,000. Lost $700. Hopefully it's done something to earn you some money over that time to make up for that $700. Okay. The negative sign, it's less than it was worth before. The relative change, go get them. How would you do the relative change on this? Yes, sir. Yeah. You're going to take your absolute change, this negative 700, and put it over the 300 or the 1,000? The 1,000, the original value, which is going to be a negative 0.7, and you multiplied it times 100, right? Which means slide the decimal 2 places, negative 70%. That means you've lost 70% of the value of that machine. It's okay, you know what's going to happen, okay? Like with a car, when you buy it, do you really expect it to go up in value as you drive it more? Okay. They're just tools that you use. Does that make sense? Easy pickings for Friday's quiz? Okay, so there you go. And I'll erase this stuff so you can actually read what's there. Negative 70%. Okay. Absolute difference tells you how much it has changed. Relative difference allows you to make a comparison. There are times where having a relative difference is important. For example, suppose I walked in the door fuming and slammed the door. I can't believe they raised the price $3. That's ridiculous. They raised the price $3. Can you believe that? And I go on and on about the $3 raise or increase in the price. Well, it depends on what $3 is being compared to on whether it's a major change or not, doesn't it? Suppose Harvest Land dumped diesel, okay? We've got tanks, we buy diesel hundreds of gallons at a time. if they raise the price from $2.99 a gallon to $5.99 a gallon, is that a big jump? They doubled the price, didn't they? Do you think I'm going to be happy about them doubling the price? Not so much. So, a $3 jump on a $2.99 item is a big jump. It's basically doubling the price, a little bit more. If, on the other hand, it's, dude, what's the problem? What'd they raise $3? Well, we were going to buy this 100 acres behind us. We can't afford 100 acres that I know of at this point. Okay? They had it priced at $1 million, and now they want $1,003,000 for it. Can you believe it? In that case, is that really a big change? Really, dude? $3 on $1 million deal? Where the relative difference is important is it allows you to put it in perspective to where you started. If you started at $2.99 and increased it by $3, that's a big jump. If you started at $1 million and raised it by $3, that's nothing. So that's why it's important to have relative differences. Now, what folks will sometimes do, if they're trying to mislead you, is they will intentionally give you an absolute difference to make it sound like a lot, where relatively speaking, it's not much at all. Okay, so you got to be careful. Does that make sense to everybody? Okay. Be careful what you're thinking. All right, here's one. When you go shopping for a job someday, some of you I know are pretty well rooted in Cincinnati. You've got house, family, other folks have jobs, and you're not moving. You're here. Okay? Some of you are going to go shopping and say, the whole United States is an option, and gosh, if Europe comes up with a good deal, I might consider that too. Okay? Average pay for full-time wage earners varies from state to state. You all know that, right? Okay? When I graduated from the doctoral program, I shopped. I looked some over around Virginia and the East Coast, around Ohio, out west, just shopping around, curious to see. Figured that was my big chance if I was really going to make a move and change things. That was it. Okay. New York is first in average pay. Ooh, Dover. Sounds like New York is the place to go, doesn't it? South Dakota ranks last. Yeah, well, let's skip South Dakota as a place to look for a job, right? Let's all go to New York. They've got the highest average pay of any state in the nation. It's probably still true. So does that mean New York's the place to go for a job? No. Why not? They got the highest pay. That's right, you got to watch cost of living. They also have some of the highest taxes. Their average tax rate's right around 50 to 55%. That means half of your paycheck automatically leaves in taxes before you ever get it. Out of every $1,000, they're going to take $500 in tax or more. Dakota, you get to keep a whole lot more of that. South Dakota. Okay? Compare the average pay in South Dakota to that in New York in both absolute and relative terms. Compare the two, 60,300 to 32,800. Okay. Do you see that New York is going to be the reference value the way this is worded? Compare South Dakota to New York. What is the baseline that we're using that everything else is being sized up against? New York is what stuff is sized up against here, isn't it? So the first thing you need to do is you need to figure out what your reference value is, identify that, identify what your new value is. With that in mind, does that make sense to everybody? You got to be careful. The absolute difference is going to be the South Dakota pay compared to the New York pay. Now, I just mentioned, or I thought I mentioned here, okay? South Dakota, North Dakota, their salaries have changed, right? What's happened there? It may have been in the 8 o'clock. Sorry, sometimes it becomes a blur after a while. What's happened in North and South Dakota to cause people to move there? Yeah. Oil. You got it. Oil. Fracking. They are paying killer salaries now in North Dakota and South Dakota. Okay? Here's one for you. What country has the largest oil and gas reserves in the world? Israel? Russia? Saudi Arabia? Venezuela? Did you know Venezuela has a ton of oil? Did you know that Venezuela is bankrupt? How could they be bankrupt when they've got huge reserves of oil? Yeah. Yeah. They actually voted in a socialist government. If you look, okay, go on YouTube, look it up. Average person in Venezuela lost 11 pounds last year because they're all dieting, right? No, they're starving in that country. They've got some of the largest oil reserves in the world, and they are starving because of the government they voted in. Yeah. Largest oil and gas reserves in the world are right here in the United States. They estimate that based on the present ways of extracting and stuff, U.S. has enough oil to run the entire world for about 200 years. If nobody else pumps a drop of oil. Whoa. Okay. So, South Dakota's salaries have gone up. But based on this, do you buy that it's going to be a negative value because the salaries there are lower than in New York? Do the relative difference? Okay. Notice we're going to take this negative 27,500, and that's what's going to land here in the numerator, isn't it? So when you do the absolute difference, you've already done part of the work for the relative difference. Okay. Do the subtraction and the multiplying and all that. Holy mackerel. Big difference there in salaries, isn't there? But that's before taxes. And not only do you take a hit on taxes, but where is a house cheaper? South Dakota or New York? Your money goes further in South Dakota. Actually, think about this for a minute. In New York City, you may make $60,000, but how much are you taking home? About 30,000. In South Dakota, you may make this, but let's see, 32,800 times 0.7. It's about like Ohio. Okay, 22,960. So in South Dakota, you're taking home about 23,000. In New York City, you're taking home about 30,000. Wow, that's a big difference there, isn't it? New York's still taking home more, but try and buy a house on 30,000. You can do that in South Dakota. How much do apartments rent in New York City? I'm not talking luxury. I'm talking a little one-bedroom apartment. Or maybe an efficiency, a studio. 1,800 is about the starting price for a studio type thing in New York City. You can buy a sweet house in Ohio for $1,800 a month. Okay, does this make sense? Now, if we reverse things and we compare New York to South Dakota, what does that do to the numbers? It switches them, doesn't it? And now, if we were to do New York compared to South Dakota, the original would be the 32,000, and the new would be the 60,000. The percentages would change, the actual difference would change. Okay, and you come up with completely different numbers depending on which way things are compared. You got to be careful. Okay. Real important. If the new or the compared value is a percent more than the reference value, okay? The way you figure it out is you do the 100% plus whatever that percent is. For example, okay, Lauren graduates here in about 4.5 years or so. She gets a job as an engineer. And I'll still be teaching at that time. And I make comment that, you know, on Lauren's first job, she is making 7% more than I am making right now. Which is probably true. Her first day on the job with her bachelor's degree, she'll be making more than I will with a PhD. Okay? Different jobs pay different wages. If you knew my salary, okay, let's say it's $80,000. Whoa, Chuck, that's a lot of money. And I've been teaching for 40 years now. Okay, so that's 40 years of raises and stuff. If I'm making 80,000, what would Lauren be making? Well, it's 7% more than that, isn't it? Well, how would you do 7% more than that? Well, it's going to be all of that 80,000, isn't it? Plus how much more? 5,600 more. So what you could do is you could take the 100% that Chuck makes and throw in another $5,600, and Lauren will start at $85,600. Okay. One of my cousins, she's a petrochemical engineer. You know what her starting salary was? Over $200,000 a year. That was her starting salary. Okay. Whoa. It's not an easy job. That's why they pay so much. A quick way to figure this out. One way to do it is to say, okay, we're going to do the 100% of Chuck's salary. Whoops. Well, it just really bounced forward, didn't it? We're going to do 100% of Chuck's. Then we're going to do the 7%, which is another 5,600, and we can add them together. That's one way to do this. Now, what's being suggested here, what's underlined, 100 plus P, is to say, okay, let's do it at one gulp. We're going to do the 100% of Chuck's salary plus the extra 7% that Lauren makes. And notice they're both percentages, so you can add them together, 100% plus 7%. That's legal. That means she's going to be making 107%. Does that make sense? Now, just for grins, take that 80,000 times 1.07. Boom. And what do you get? Whoa, check it out. It's the $85,600, isn't it? There are two ways to figure out something more than. Well, there are several ways. Two of those are the ways we're talking about here. One is to first take the 100% and whatever the other percent is, and then add them together. The catch there is you're adding two big numbers, aren't you? The other way is to avoid adding big numbers and add the 100 and the 7% and let the calculator add them together for you by doing the computation. Which way's right? Either. Okay? Either way is fine. Okay? They'll both get you there. It's just which one are you more comfortable with? Less than. Got about 5 minutes, so yeah, we'll get this done. Something is less than. Well, you follow the same basic pattern as before. Before, if it was more than, we added the percentage to the original 100%. If it's less than, guess what you do? Subtract the percentage. Okay? So, a special on fertilizer, and it's 6% less than what they were selling it for in July. You go to a store and they've got 15% off. That means it's 15% less than it would have been, doesn't it? Okay? Odds are you're not going to be buying much fertilizer. Not this year. Let's go with the store. And they tell you everything is 15% off. It's 15% less than it was. How do you figure out the price of an item? You're looking at a jacket. The jacket is originally priced at $120. And it's 15% off. That means it's 15% less than the original price, doesn't it? Well, one way to do this would be to take and figure out what's 15% of $120. And then take the 120 minus that number. So you got to do some multiplying and subtracting, don't you? And neither number is real comfortable to work with. The other way you can do it is you can say, well, it's 100% and it's 15% less. So you're really going to pay what percent of the original price? Yeah, 85%. So it's going to be the 120 times the 85%, but wait a minute, you multiply it as a percent, equals, so it's 15% off the 120 times 0.85. How much is the jacket now? $102. Does that make sense how those discounts work? Okay. Uh-oh, Carol earns 50% more than William. How would you figure out her salary? Yeah, let's say William makes $45,000. Where'd I get $45,000? Just made it up. Okay? If Carol earns 50% more, we're going to take this $45,000, and what are we going to multiply by? It's going to be 100% of Williams plus 50% more, which gives 150%, which means when we bring it over here, we're going to slide the decimal 2 places, and it's going to be 1.5, isn't it? Does that make sense? So it's going to be the 45,000 times 1.5 equals, oh, she's making 67.5. Not bad. Hey, are you noticing something here? First, it's 1 minute till. What's going to be real handy to have Friday? Calculator. Do you really want to be doing all this stuff by hand? No. Make sure your calculator has good batteries in it. Well, this should be okay. They've been in there for 3 years and they've always worked before. If they've been in there for 3 years, that's a hint that it's time to replace them. Okay? So, get good batteries in it. You don't want it dying on the test or a final or some crazy thing like that. Okay? I will get some homeworks posted. They'll be due for Friday. I hope you have a good day.
So we have